Right now, as you watch this, you are completely surrounded, not by air, not by sky, but by a structure so enormous that the entire solar system sits inside it like a grain of sand, inside a stadium, and almost nobody knows it is there. Our solar system is our corner of the galaxy, 8 planets orbiting an ordinary star. And they all do something curious. They travel within roughly the same flat plane. Not by coincidence, by inheritance, the enormous cloud of gas and dust that collapsed to form the sun, and everything around it billions of years ago began to spin as it contracted. Spinning objects flatten. The result was a disk, and the planets formed inside it. Picture a giant racetrack, 8 planets circling the sun along the same level surface, a plane aligned closely with the sun's own equator. But not perfectly. Every planet tilts slightly, Mercury by about 7 degrees. Pluto now classified as a dwarf planet by nearly 17. And comets don't follow the rules at all. Many arrive from distant regions along orbits so steeply angled that they cut through the solar system almost perpendicularly, like a needle punched through a vinyl record. So the planets have their disk, but above and below it, what is actually there? The answer is not what you expect. Before we get there, we need to confront something more fundamental: up-down. 2 words that feel completely obvious on Earth. Gravity pulls everything towards the planet's center. The ground is beneath your feet. The sky is overhead. Simple. In space, that logic does not exist. There is no fixed floor. There is no universal ceiling. An astronaut floating in orbit has no objectively correct orientation. They could be upside down relative to another astronaut nearby, and neither of them would be wrong. A galaxy that looks upright to one observer appears completely tilted to another. Direction in space depends entirely on the reference point you choose. So, when we talk about above and below the solar system, we use the plane of planetary orbits, the ecliptic, as that reference. A tool, an agreement, not a physical reality. With that in place, we can look at what actually lies in those directions. And what we find is extraordinary. The first structure above and below the orbital plane is one of the most mysterious things in the entire solar system. Most people have never heard of it. The Oort Cloud. It is not a disk. It is not a ring. It is a vast spherical shell surrounding the entire solar system in every direction, above, below, and all around. Scientists believe it extends somewhere between 50,000 and 100,000 astronomical units from the Sun, stretching up to about a quarter of the way to Proxima Centauri, the nearest star. Inside this shell, trillions of small frozen objects, water ice, ammonia, methane, the leftover raw material from the solar system's formation, hurled outward billions of years ago by gravitational interactions with Jupiter and Saturn. Some escaped entirely, others were caught in vast, slow orbits at the very edge of the Sun's gravitational reach. The result is an invisible bubble, encasing everything we have ever known. We have never seen it directly. No spacecraft has reached it. No telescope has imaged it. It exists as a theoretical structure, built from indirect evidence. The most compelling clue comes from long-period comets, those that take thousands or even millions of years to complete a single orbit. They arrive from all directions, not just from the flat plane of the Kuiper Belt. Their trajectories point to a spherical origin far beyond the known planets. That is the Oort Cloud, surrounding us, silent, invisible, enormous. Further out lies another structure, one that envelops the solar system above, below, and in every direction. The heliosphere. The Sun constantly releases charged particles, the solar wind. As these particles stream outward in all directions, they eventually collide with the gas and dust drifting through interstellar space. That collision creates a boundary, a protective bubble encasing the entire solar system. The heliosphere is not a perfect sphere. It is a distorted teardrop, compressed on the leading side where the solar wind pushes against incoming interstellar material, stretched into a long tail behind us, shaped by the solar system's movement through the galaxy, the same way a boat moving through water creates a wave in front and a wake behind. The outer edge of this bubble, where the solar wind finally loses its battle against interstellar pressure, is called the heliopause. Beyond it, true interstellar space, cold, vast, mostly empty, but not completely. Just beyond the heliopause, the solar system is currently passing through something called the Local Interstellar Cloud, a region of slightly denser gas and dust, not dramatically different from surrounding space, but enough to notice. The Sun has been traveling through it for some time. It will continue for thousands of years before moving on to the next region. Because the solar system is not stationary, it is hurtling through the galaxy at around 828,000 kilometers per hour, passing through different environments, some denser, some thinner. The local cloud is just one stop on a journey that never ends, and the environment we currently occupy is one of the stranger ones. The solar system sits inside what astronomers call the local bubble, a region of space roughly 300 light-years across. Unusually empty, the density of gas and dust within it is far lower than the galactic average, a vast, hollowed-out cavity carved into the surrounding material. What made it? A series of supernova explosions, massive stars that ended their lives in catastrophic blasts millions of years ago, pushing the surrounding gas and dust violently outward. Multiple explosions in the same region over millions of years. The result was a void. The local bubble has walls, denser regions at its edges where expelled material has piled up. Our solar system sits inside this cavity, moving through it, surrounded on all sides by those distant walls. Beyond them, more clouds, more bubbles, more structure, layered in every direction across the galaxy. This changes everything about how we should picture the solar system. The image most people carry, planets arranged neatly in a flat diagram, isolated and self-contained, is wrong. The solar system is not a flat chart. It is a three-dimensional structure embedded in a far larger and more complex environment, with layers extending above and below in every direction. Above and below us right now, the Oort Cloud, the Heliosphere, the Local Interstellar Cloud, the walls of the local bubble. And surrounding all of that, the Milky Way itself, and which is not perfectly flat either. It has a central bulge, spiral arms, a slightly warped outer edge. Around it sits the galactic halo, a roughly spherical region containing older stars, star clusters, and vast amounts of dark matter extending far above and below the galactic plane. By studying how stars and gas move relative to this plane, astronomers trace the history of star formation, supernova, and the distribution of dark matter across the galaxy. At every scale, up and down mean only what we decide they mean. And in every direction, there is more to find. The solar system moves through all of this like a ship through an ocean, creating disturbances, passing through currents, drifting through regions carved by events that happened long before humans existed. We are not orbiting the sun in an empty void. We are part of a living, moving, layered structure stretching in every direction into the unknown. And somehow, in the middle of all that vastness, on a small planet, tilted slightly off the orbital plane, life appeared. That remains the most remarkable fact of all.